Habiters. I'm Habiter Owen for our Extra Math Challenge. And our Extra Math Challenge for today is all about nature of the roots of a quadratic equation. These are quadratic examples of quadratic equation. So we're going to identify the discriminant and the nature of the roots. To solve for discriminant, we have to use this formula, b squared minus 4ac. So let us solve for equation number 1. X squared minus 4x plus 4 is equal to 0. So first, let's identify the values of the variables. So a, b, c. The value of a is 1. The value of b is negative 4. And the value of c is 4. So now that we have identified the values of the variables, we're going to substitute the values in the formula. So b is equal to negative 4, square it, and 4, the value of a is 1, and the value of c is 4. So now we're going to solve this expression. So negative 4 squared, or negative 4 times negative 4, is equal to 60, minus 4 times 1 is equal to 4 times 4 is equal to 16. So 16 minus 16 is equal to 0. So now that we have identified the discriminant of this equation, the nature of the roots of this equation is real, rational, and equal. Now that we have solved the number 1, we're going to move to equation number 2. Equation number 2, x squared plus 2x minus 4 is equal to 0. So again, let us first identify the values of the variables a, b, and c. So the value of a is 1, the value of b is 2, and the value of c is negative 4. So now that we've identified the values, we're going to substitute the values in the formula. So b is equal to 2, we're going to square it, minus 4, the value of a is 1, and the value of c is negative 4. So now let's solve this expression. So 2 times 2, or 2 squared, is equal to 4, minus 4 times 1 times negative 4 is equal to positive 16. So now let's add these two numbers. 4 plus 16 is equal to 20. So now that we have identified the discriminant of this equation, we're going to identify the nature of the roots. So it is real, rational, and unequal. Okay, so let's move to equation number 3. Okay, so equation number 3, x squared minus 6x plus 2 is equal to 0. So let's identify the values of the variables. So A is equal to 1. B is equal to negative 6. And C is equal to 2. So now that we have identified the values of the variables, we're going to substitute again the values in the formula. So B is equal to negative 6 to square minus 4, and the value of A is 1, and the value of C is 2. So we're going to solve this expression. Negative 6 times negative 6, or negative 6 squared, is equal to 36, minus 4 times 1 times 2 is equal to 8. And 36 minus 8 is equal to 28. So now that we have identified the discriminant, we're going to write the nature of the roots. So it is real, rational, and unequal. Okay, so let's move to equation number 4. Last equation. Okay. So number 4, x squared plus 5x plus 7 is equal to 0. So first, let us identify the values of the variables. So A is equal to 1, B is equal to 5, and C is equal to 7. So now let's substitute the values in the formula. So B is equal to 5 squared minus 4. The value of A is 1, and the value of C is 7. So we solve this expression. 5 times 5, or 5 squared, is equal to 25, minus 4 times 1 is 4 times 7 is equal to 28. Okay, so 25 minus 28 is equal to negative 3. So now that we have identified the discriminant of the equation, the nature of the roots is it has no real roots. So I'm going to explain later why it has no real roots. Okay, so we're done we're solving for the discriminant. So explain. Actually, in general, there are 4 cases to identify nature of the roots of a quadratic equation. So first case is if b squared minus 4ac is equal to 0, then the nature of the roots of this equation is real, rational, and equal. The second case, if b squared minus 4ac is greater than 0 and it is a perfect number, then the nature of the roots is real, rational, and unequal. In the third case, b squared minus 4ac is greater than 0, but it is not a perfect number, then the nature of the roots are real, rational, and unequal. In the last case, if b squared minus 4ac is less than 0, then it has no real roots. So that's all for today. Thank you very much.